should always take the greatest common factor of a polynomial before you factor. And I'm going to do one more of those types of problems before we lead into the next type of problem that has a polynomial that has 4 terms. There's going to be an intermediate step that we're going to look at, and we're going to conclude with factoring polynomials that have 4 terms. Please just be reminded that if you have an expression such as this one, that you should always look for the greatest common factors first. And I've noticed that there's no numerical value that will divide into each one of these terms evenly. So what I have to look for next is if there's a common factor of m that appears in every one, and there is. And if there's a common factor of at least n, and it looks like just n to the first appears in every one, and that's all I can factor out of this expression. So I'll need a 10 here, and I'll need an m, because this m times m is m to the second power. N is already covered. I'm going to need a minus 21 in the second term. I've got mn here, so I need another factor of n in order to result with the n squared. And finally, I just need a minus 13. I'm going to sound like a broken record through the rest of these 5 segments because I'm always going to say to you, take the greatest common factor out first and then count the number of terms. With that, let's look at the situation where we... Intermediate step, I'd like to have you look at the next problem and see that we're taking the greatest common factor out of 2 terms. Like in this problem, 2x plus 8, where I would factor out the 2 first and be left in the parentheses with x plus 4, I'd like you to notice that in this problem right here, think of, if you will, this expression right here as a term, and the second that's follows the plus sign as another term. And would you notice this u minus v that each of these terms have in common? Like these 2 terms that have a common factor of 2, I'm going to factor this u minus v out of each of these terms. And when I do that, I'm going to write it down just one time, like I did right here. And what I need in the second set of parentheses is the factors that remain. Like here, I needed an x, because 2 times x is that 2x. When I factor the u minus v out here, I need to put a y in the front part of the next binomial. And when I factor this u minus v, out of that expression, I need a plus z here. I'm done. That's the factored form. Again, it's an intermediate step of the situation where we factor with 4 terms. Again, another problem like the previous one, where we have, if you will, think of this as 2 expressions, each of them having a common binomial. In this case, a minus b is common to each of these terms, and I'm going to factor those out and write them down one time, as when I take the greatest common factor out. And in the next set of parentheses, I'm going to need this factor that was left alone, if you will, and this minus 3 in the other set. And again, I've finished factoring. Now we'll complete a full problem. The problem that I'm going to demonstrate next has 4 terms. What we're going to do is we're going to factor this by a process that's called grouping. We're going to look at the first 2 terms, and we're going to group those. And we're going to look at the second 2 terms, and we're going to group those as well. I've provided you with a flow chart in the Course Compass website. You should print that, and on that flow chart it describes the process of factoring by grouping when there are 4 terms. And the first step says to group the first 2 terms and group the second 2 terms, and you can rearrange them if you need to, and to take the common factor out of each of those groups. So let's do that. In this group right here, there's a common factor of z. I'm going to take that common factor and remove it. And now I'm going to write inside the parentheses c plus d, because this product, if I were to distribute it, z times c is this first term, and then this product right here is the second term. Likewise, in this second batch of grouping, I'm going to factor out a positive w. And when I do that, I need a c plus a d, so that when I distribute this, I will have the original first term, and here the second term. And now what we see, this is the intermediate step we started with a minute ago. We see that we have a common factor, or a binomial, that I'm now going to factor out. And with that, then the factors that are left behind, this z and this w, having to go in their second set of parentheses. And finally, the nice thing about this whole chapter is that I can check all of my answers. Let's do that fairly quickly. I'm going to FOIL this. So c times z is cz. That's this term originally. C times w is cw. That's this one right here. Then the inner terms, their product is d times z, that's this term. And then finally the last, that's d times w. And I see that I have what I started with. This is the answer. This is what I'm looking for. This is my check. Another problem with 4 terms. Again, my broken record goes on and asks you every time to look for the greatest common factor first. In these 4 terms, there is no numerical value that divides into every one evenly. Nor is there an x term in every one. Therefore, I can go ahead and say this problem has 1, 2, 3, 4 terms, and so I should factor this by grouping. So I'll group the first 2, and I'll group the second 2, and now I'm going to go about taking the greatest common factor out of those groups. So between a 10 and a 25, the numerical common factor is a 5. X occurs in both of those. I can take at most x squared out, and as a result, I'll need a 2x here so that this product will give me the 10x cubed. And I need a minus 5 as my second term, so 5x squared times a minus 5 will give me a minus 25x squared. In the second batch of grouping, parentheses, the greatest common factor is a 2. So I'll factor that out, and I'll need a 2x here, because 2 times 2x is 4x, and I'll need a minus 5 here, because 2 times that minus 5 is a minus 10. And we see then that these binomials do match. They either will match, or you can move these terms around and try again, or the problem doesn't factor. So I will remove that common factor of 2x minus 5, and in the second set of parentheses I need this factor in the first grouping, the positive 2 from the second, and finally I could FOIL this in order to check it. The dilemma with factoring by grouping when there is 4 terms that occurs for some of us is when there's a minus sign in between the second and the third term. And I ask you just to be very cautious there. The 2 problems that we've done up to this point have both had plus symbols. This problem doesn't have a greatest common factor in all the terms, so I'm going to go ahead and group the first 2 terms. But I ask you to be cautious. You've got to make sure that the minus sign that belongs with this CX goes inside. Remember that every subtraction problem can be changed to, or you can show as add the opposite, and group that minus sign inside the grouping symbols. Lots of reasons you'll see as we finish this problem. Let's go ahead and take the greatest common factor out here. In this case it's a b times x minus y. And in this case it's a c. I've got a plus sign down here, and a lot of people will just factor out a c. I would like you to notice that in this problem you have to factor out a minus c, because what you need right here is a binomial that's going to match this one. And unless you factor out a minus c, you won't get a positive x as your first term. A minus c times this x is this minus cx, and I'll need a minus y here because a minus c times a minus y will give me the plus cy. And by factoring out a minus c, I have forced these binomials to be alike. It would not have happened otherwise. You would have had a plus c here and then a negative x plus y, and you would have said, I can't finish this problem. So when there's a minus sign in front of the third term, would you keep that inside the parentheses? It's most likely, more likely than not, you will factor out a negative, whatever the common factor is, and then we'll finish the problem with x minus y as the common binomial, and b minus c in their own set of grouping symbols, and I'm done, and I should multiply it or check it. Here's the last problem that I'd like to demonstrate where there are 4 terms involved. Like the previous problem, the sign between the second and the third terms is a minus sign. So would you please think to add the opposite? And then go ahead and group the first 2 terms and the second 2 terms. And here it's very plainly, you can see that the common factor is 7x squared. Don't forget to take x squared out. And then I'll need an x minus 2 in the parentheses. Just check it to make sure this works. 7x squared times x is 7x cubed. 7x squared times a minus 2 is a minus 14x squared. Look at what's in the binomial here, and look at your next grouping. Number 1, there are not numerical values, it appears, or variables that can come out, and if that's the case, you have to factor out a 1. At least do that. But this binomial does not match this binomial exactly, so it appears as though I'm going to have to factor out a minus 1 out of this pairing. And when I do that, I'll have a positive x here, because a minus 1 times x is that minus x, And I'll have a minus 2 here because a minus 1 times a minus 2 is that plus 2. And by factoring out the minus 1, the common binomial factors do appear of x minus 2. I'll factor those out of each term. Then the 7x squared and the minus 1 go in their own set of parentheses, and I'm done. And I'll check it by multiplying. We're going to go on in our next segment to factoring trinomials. Two situations. A trinomial is a polynomial in 3 terms. We'll be looking at a simple situation first where the coefficient in front of the first term is a 1. And then the second situation is where the coefficient will not be a 1.